once. And if I have a discriminant less than 0, it does not touch my x-axis. It will look something like this. Okay? So now let's kind of pivot and let's kind of get back to the quadratic formula. So obviously, what is our quadratic formula going to help us determine?
How many times x-axis is such enough?
That's our discriminant, and our discriminant is a part of the quadratic formula. So what is the entire quadratic formula going to help us find? The x-intercepts. It's another method to find the x-intercepts. Okay? So we have this process. So before we go into the process, you have a box at the bottom of your page. How would you determine the x-intercept, and what does it show? Okay? I want you to think about that. Write a sentence or two really quickly. How do you determine the x-intercept? So far, how would you tell me, how would you figure out what the x-intercepts are? And what does it show? What does an x-intercept show? Go ahead and write that down really quickly on your paper. In a sentence. Give me a sentence or two. Give me a sentence or two. If I ask you to find my x's, okay, how would you do that right now? Using what you know. Think about the bell ringer. What did you do in the bell ringer? What does an x-intercept look like on a graph? Those are the things I want you to start telling me right now. And not back to the bottom of the page.
No. Read this,
Okay, right here.
read this,
Right
and
here.
answer this.
So b squared minus
Read
4ac,
this,
b squared
and
minus
answer
4ac,
this.
and so on and so forth.
Okay, this one. Read this and answer this.
Right here, you need to write b
Read
squared
this
minus
and answer
4ac.
this.
So the
What do you mean?
discriminant, that's going to tell us the numbers.
The x-intercept with y is equal to what? Okay, just come on. When y equal.
Okay, you make sure you write your discriminant, so b squared minus 4ac, b squared minus you.
What does it show?
Right here,
Intersection
guys, I know some of you missed that in these boxes, the discriminant. So b squared minus 4ac, when it's greater than 0, you have two solutions. And so on and so forth. And then I need you answering these
Why?
questions.
Perfect.
Write your answers right here, and then I want your b squared minus 4ac.
Okay, you don't listen what you said. You put it here. Discriminate.
It still is.
This is discriminate. B2 minus 4ac.
See what
B2
happens.
minus that. B2 anterior. You know what she said? You have to discriminate. What is
So I need everyone to wrap it up. I'm gonna give you another 30 seconds to talk to me about how you determine your x-intercepts. Right here, you're gonna want b squared minus 4ac, b squared minus 4ac, b squared minus 4ac.
No, come in.
Okay?
So here.
Wait, what does that do?
Discriminate. B2 minus 4ac. What is it? B2 minus 4ac.
Okay, good, Ashley. Good, good. I'm gonna need you to stay with me for a little bit longer, okay? Stay with me a little bit longer, so you guys
And the other one
do
too.
this.
The other
See, we're
one
gonna
too.
be at independent
The
practice.
other one. But this one too. Yeah, perfect. The same one.
Yes.
And the same
All
one.
right, I need it back with us in 3, 2, 1. I need everybody up here. James, Shay, Samantha. Okay.
And the same thing.
On the next page, we have our process chart, right? Quadratic formula process. You're missing number 1. What is number 1? Standard form. You need to make sure that those equations are in standard form. Let's go ahead and start filling in our process.
Next page.
Yes. Okay. We need to make sure we are in standard form. Step 2. We need to identify our A, our B, and our C. That is so important, right?
Same one.
How else will we know what to fill in the quadratic formula?
What is the standard form?
Step 3. Write the quadratic formula.
The standard form. Oh, okay.
Step 4. Uh-oh, there's some repetition.
Same thing.
Write the quadratic formula.
What is that one?
What? Write it in. Let's go. And step 5. Write the quadratic formula. They are not going to give you the quadratic formula.
Number 4.
It is our job to remember every single little piece of that quadratic formula. So we're going to do that By checking ourselves. When we write it each time, we're kind of checking ourselves. We're making sure we have every single part.
A is equal what?
3 times.
A is
1, 2,
equal
3.
what? What number say?
So every time
One. The coefficient.
we need, we're gonna write it 3 times. So we're making sure that we have all of those negatives, all of those plus or minuses,
What is it?
all of those. All right. Here we go. Then we have 6. We're going to simplify. Yuri.
Yeah.
So, on the other side, we're going to go step by step. We have 1, okay? Step 1, make sure it's in standard form. We're going to go ahead and fill in x squared minus 3x plus 2 equals 0. You're missing an equation. Let's go ahead and put that right in there. Okay, let's go ahead and write that in. Is this in standard form?
Yes.
Okay. Step 2, we need to identify our A, B, and C. So we need to identify our coefficients.
2.
My coefficient for A is 1. My coefficient for B, this is where you need to be very careful. You take the sign with it. It is negative 3. That sign will throw off everything. Okay? Huh?
How?
How'd I get 1?
Yeah.
What's the coefficient in front of X? There you go. Alright, and what is my C? 2. It's a positive 2. We have to take the sign that's in front of it. Okay? Step 3, write the quadratic equation. I wrote it for you once. So you need to write it in for step 4. Negative B plus or minus the square root of B squared minus 4AC all divided by 2 times A. It will always be this. The quadratic formula is so stable. So it's never changing. Okay?
Stable.
Stable. The only thing that's changing are our values of B, A, and C. But that 4 stays the same, this 2 stays the same. It's always going to be a negative B. Okay? And really take note of this plus or minus. Okay?
So,
Hold on, Jim. Step 5. You write the quadratic formula. And step 6, we're going to simplify. So where our value of B, what's our value of B? Negative 3. So you're going to write in a negative 3 on your paper. Where do you see B? You write in the value of B, which is negative 3.
Bless you.
Next we have 4 times A. Our A is 1. Let's plug in the value of 1. We're using substitution right now. C is 2. All divided by 2 times A, which is 1. Okay? Good. Yes. Okay.
examples now?
Okay. From here, I'm going to have you all watch from here, and then we're going to do an example together, and then we're going to get straight into independent practice. So from here, I have x equals negative 3. This negative always stays, and I substituted for the negative 3 plus or minus the square root of. Now all this, remember the discriminant is all under the square root. So we have b, which is negative 3, squared minus 4 times a, which is 1, times c, which is 2, all divided by 2 times a, which is 1. And now we know to simplify, right?
Yeah.
So we are going to go ahead and simplify. X equals negative times a negative gives me a the positive 3. Good, Gerald, you're ahead of the game. Okay? Plus or minus, that is so important to keep. You'll see why in 1 second. let's pause. What do you think this plus or minus is telling us?
That it could be positive or negative.
That could be positive or negative, or what else?
The or is not equal.
Say that nice and loud.
You gonna have two solutions.
You may have 2 solutions. When do we know if we have 2 solutions? What can we use to figure out how many solutions we're gonna get?
Exactly.
Answer is greater than
When the answer is greater than 0, when what answer is greater than 0? What do we call it?
X.
Intercept.
The
Discriminant.
discriminant,
Yeah.
okay? So we have negative 3 squared. What is negative 3 squared?
No,
20.
97.
Positive 9. Negative 3 times negative 3 gives me a positive 9.
Well, you said.
Okay. You gotta take your time, right? Gotta take our time. Minus 4AC. So we do 4 times 1 is 4. 4 times 2 is 8. There we go. No.
We're not doing examples right now?
No, I just want you to watch this. We're not gonna say negative 8. We're gonna leave our sign. We're gonna do our multiplication. Okay, so 4 times 1 is 4. 4 times 2 is 8. Okay? Now, all divided by 2 times 1, which is 2. Okay, now let's continue to simplify. We have 3 plus or minus the square root of, well, 9 minus 8 is 1. All divided by 2. Okay, I'm going to bring this on up here. Now, what is the square root of 1? 1. Okay. Let's take a side note just to use the calculator. To find the square root, if you can't remember if it's a perfect square or not, you enter in the number that's in the radical, hit shift, and the x to the second power button, and it will give you the square root. Okay. Now, so now we have x equals 3 plus or minus 1, all divided by 2. So this is when we split, okay? So now I'm left with x equals 3 plus 1, all divided by 2, and x equals 3 minus 1, all divided by 2. When I simplify and solve, I get x equals 4 divided by 2, x equals 2, and I get 2 divided by 2, x equals 1. Here are my 2 solutions, okay? Okay, so, okay, we're going to do one example together, and then we're going to get going. But what I'd like us to think about before we do that example together, all right? What if, when I had a number in my square root, what if it was like 5? Is 5 a perfect square?
No.
No. Okay, the square root of 5 is not going to give me a nice whole round number. When might it be a good idea to leave it as an irrational number? Can you ever think of a case in which we might want to keep it as a decimal or as an irrational number?
When we find the slope.
Okay, not the slope. So let's think about it this way. If I ask a question, okay, and I say, I have this word problem, and I start talking and I say, okay, when you see the 0, that could be my age. Am I going to have a negative age?
No.
No. So I would know that whichever one, let's say I got 2 solutions and one was negative, and they said which is the best answer, I would choose the positive one, right?
Yeah.
Because you can't have a negative age. So when might it be a good idea? Can anyone think of an example of when we might want to keep an irrational number, when a decimal might be an appropriate answer?
We have to find out.
When they're asking you weight.
Hmm?
When they're asking you kilograms,
Okay, when they're asking you a weight. Good. Okay. I just want us to think of that, keep that question in the back of our minds as we tackle some word problems later on. That's something we're going to come back to. So I just wanted to pose that question to you all. Okay. So let's get started on our example together. Then I'm going to release you guys to do independent work, and you're going to be working for the rest of class. Okay?